Alright, assume that adults have IQ scores that are normally distributed with a mean of 100 and a standard deviation of 15. Find P sub 20, which is the IQ score separating the bottom 20%. So in other words, if I have my normal distribution, okay, and that's in the middle is my 50%, right, because that would be halfway, then what I'm looking at is this lower 20% or 0.20, which will be what's in the table. And so remember, these 4-digit values in the table, these are the probabilities. So what I'm looking for is I'm trying to find the closest value to 0.20. So I start looking around here and I see, oh, okay, it looks like, I lost it. It looks like this would be the closest I could get to 0.20. And you could write 4 digits. And so the z value then would be negative 0.84. So I'm in this row and this column, so that would be my z value. Alright, so what do I do with that? Well, they've given me this other information, and remember we have this formula that z equals x minus mu over sigma, which is my standard deviation. So they want, here it's, I want to actually find, okay, the IQ score, so I'm looking for the x value. So I could solve this, do some algebra stuff and solve this for x, meaning I can multiply both sides by sigma, and then I could add mu to both sides. And what this does is this gives me this in terms of x. And now they've told me some things up here. They've told me the mean is 100, so I can plug that in. I just found my z value, which is negative 0.84, and they told me the standard deviation is 15. So if I multiply all that stuff out, I get 87.4, which makes sense because that's saying this would be at 87.4 when the mean was 100. So it would definitely be something less than 100.